Mr. Kurgan, and I'm here today to talk to you about the key concepts in our science notebook. So I'm going to scroll here to the science notebook on my website, and when you click on that, it will open Google slide deck of the science notebook, and I'm going to scroll down here to the first unit, which is thermal energy, and we're going to take a look at the key concepts. I'm going to blow it up so you can see it. All right, so the key concept page is really looking at what are the main ideas that we covered during the unit. And what I ask students to do is once I give them the definition, molecules, things are made of molecules, right? So things we had talked about is everything. Anything that has mass and volume could be a thing. It's stuff. And so things are made of molecules. The students are asked to draw a picture, which helps them make brain identification with what the definition is. So the next key concept, number 2, is when things get hotter, molecules are moving faster. So again, we have a thermometer, it shows high temperature, and then these little arrows on the molecules show them moving faster. As we go through the unit, we may go back and revise some of the definitions, but those pictures should remain fairly similar. We might just be adding a label to something. So for example, here this third one we see the word is temperature, and so temperature is a measure of the average of the kinetic energy in the system, right? So the average speed that all the molecules are moving. And I also showed here that we have the sum of all of these different numbers, which are the speed of the molecules, and there happens to be 10 circles, so 30, the sum of all those numbers, divided by the number of molecules that we have. So the temperature is a 3. I don't know what scale that's on, but that's what that's looking at. And then we can go down and we look at energy, right? Number 6, we have the first law of thermodynamics. Don't mention that too often in class, but it's there. Energy is not created or destroyed. Therefore, as energy transfers, it increases in one part of the system and decreases in another. And we did a little experiment in class where we had a cup of hot water, right? Initially, when we put the cup in, right, the water was 66 degrees, the air was 33. And so over the course of the time, both systems came to what we call equilibrium. The cup of water decreased in temperature and the air temperature increased. So energy wasn't created or destroyed. It was just transferred from the hot water to the surrounding air in the box that we had. So these definitions, these key concepts, are used to answer all of the questions throughout the unit. And we go to the next page where we hit the final key concepts. And so this information students are going to use at the end of a unit to answer the big problem that they're given at the beginning of that specific unit. And in the case of thermal energy, when we open that unit up, we come on here to the very first thing that we did. We scroll down, the kids are given a problem, and this is going to be the problem that they're going to use over the next few weeks that they have to solve. And they had to pick between one of these two proposals for a heating system for a school in Chicago. And in this particular heating system, we have a small pool of water that's heated to 39 degrees Celsius, and it's going to be pumped through pipes around the school, and the current temperature in the school is 11 degrees Celsius. So as that water is pumped through, the hot pipes come in contact with the cold air in the room, and energy is transferred from the hot pipe to the cold air, warming the air up and cooling the water in the pipes. Eventually, we get enough warm air to warm up the school. And so the kids have to pick, is it better to have a small pool of water at 39 degrees, or should we go with a bigger pool of water at 30 degrees for essentially the same physics that goes behind it with thermal energy? but they just want to know, big pool at 30 degrees or a little pool at 39 degrees? Which one would be better to warm the school up? And that is the big question for Unit 1. And so if we go back to our science notebook and we open that up and we look at those key concepts, students are going to use these key concepts to explain, number one, how we can heat the school up, because the molecules are transferring energy in the system until the system reaches equilibrium, which is the air temperature in the school and the water temperature in the pipes. They also need to know that larger things are made of more molecules than smaller things, right? And then finally, right, for things that are the same temperature, with the thing with the more molecules has more energy. And so they're going to use these key concepts to formulate an argument to pick one of those two heating systems for the school. And that, in a nutshell, is Unit 1.